Okay, so imagine you're on Earth and you're looking out into the universe. You see all these different galaxies, and you see the light from these galaxies, and you notice all the light from these different galaxies are red shifted. That means these galaxies are moving away. So if you remember, if light is red shifted, that means the wavelength has increased, and the light from all these galaxies is red shifted, so that means they're moving away from us. But not only that, the further away a galaxy is, the faster it's moving away. So this one on the right here, which is quite far away, the light from that galaxy is really stretched. The wavelength is increased, is more redshifted because it's moving away faster. Okay, so the more distant a galaxy is, the faster it's moving away, the more its wavelength has increased. Now this means that the universe must be expanding. Okay, let me give you an example. So here this balloon represents the universe, and over time the universe is expanding like this. Okay, so imagine you're like an ant on this. So you're like this ant here, labeled X, and there's other ants which basically represent galaxies A and B. And let's say the distance from one of those ants is 1 centimeter, and the other one is 2 centimeters. And let's say over 1 second or over some period of time, the universe has tripled in size. So one of the ants that was 1 centimeter away is now 3 centimeters away. The other one was 2 centimeters away, now is 6 centimeters away. So it's increased in length by this much. But maybe you've noticed the ant that was closer has only moved away by 2 centimeters, while in that same time the ant that was further away has moved away by 4 centimeters. So this means the further away it is, the faster it's going to be moving away. And this is what we see with galaxies as well. Galaxies that are further away are moving away faster. And that's because the space itself is expanding. And it's not just that these galaxies are moving away from us, they're all moving away from each other as well. So all galaxies are moving away from all other galaxies because the space itself is expanding and the universe is getting bigger. So now let's run this backwards. So if we look into the past, because the universe is expanding, in the past it would have been smaller. Okay, so it would have started as a small region like this, which is very hot and dense. And this is what we call the Big Bang. So the Big Bang is how the universe began, we believe. It started in a small region which is very hot and dense. And the fact that it's still expanding right now is evidence that it started off with a Big Bang. That in the past it was small and in a hot, dense region. In this example, a student is attempting to explain the evidence for the Big Bang theory. We need to suggest some improvements for the student's answer. Okay, so first sentence they wrote, light from other stars shows redshift. Well, is light from other stars in other galaxies? Now, it's possible that if we look at a star within our own galaxy, it could be moving towards us, so it could be blue shifted. But when we look at light from other galaxies, almost always those galaxies are moving away and it shows redshift. So the second sentence says this means the galaxies are moving away from us. Well, they're not just moving away from us, they're moving away from each other as well. All galaxies are moving away from each other. Okay, so this means the universe must be expanding. Well, no, because we've skipped a few steps there. We add some more detail. We see that light from more distant galaxies shows more redshift. So that means the further away a galaxy is, the faster it's moving away. And I showed you using that balloon, it's this that leads to the conclusion that the universe must be expanding. Okay, the last bullet point here, this means in the past, everything must have started from one place. Now, I wouldn't just say it started from one place, I'd use what will get the marks basically. It started from a small region, which is hot and dense.